Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in. Today we look at two-way tables. Now, last time we looked at Venn diagrams. Two-way tables are essentially a way to achieve the same thing as Venn diagrams, but you might find one of them easier to understand. So as with Venn diagrams, what we want to do is we want to take a couple of categories. We want to see how many elements are in each category, and we use the two-way tables to display the information in a convenient way, and the goal is we want to use that to help us with probability calculations. So let me draw up a two-way table so you can see what it looks like. So the reason it's a two-way table, we have one way, two ways. We have two categories. So we have category here A. A could be whatever we want. It could be number of people that play soccer. B is another category. It can be whatever we want. Number of people that play footy or whatever. So remember, of course, that A dash means not A. So things that are not in that category. And obviously B dash means they're not in category B. So what we do is we have a number that goes in this cell, this cell, this cell, and this cell. So there are four numbers that go in here. And they actually correspond to the four numbers that we inserted in a Venn diagram. So the difference here is we also have some cells where we just put the total number in each category. So that might make it a little easier for you to understand. So all these black boxes go with a total. So I'm going to now populate these cells and we'll answer some probability questions. So let's say that A is the category of, say, students with blonde hair. And let's say B is the category of students with blue eyes. So this two-way table displays how many students have blonde hair, blue eyes, both, or neither. And because it displays that information in an easy way to see and understand, then we'll be able to answer probability questions quite easily. So let's say in this that I'm going to put the number 30 here. So that means this cell here means there were 30 students in category A and also in category B. So these would be the students that have both blonde hair and blue eyes. So let's say there's 25 in this cell here. So this is B because it's in this row and it's not A in that column. So B and not A means blue eyes but not blonde hair. So down here, the next cell, I'll put 18 in there. That would be A and not B. So that would be they do have blonde hair, but they don't have blue eyes. And the last cell means they have neither blonde hair nor blue eyes. So I'll just put 42 there. So those four numbers in red represent the four possibilities. They could be in category A only, category B only, in both, or neither. And that's, what would happen in real life. A student could have blonde hair but not blue eyes but not blonde hair, both blonde hair and blue eyes, or neither blonde hair and blue eyes. So the black ones, we just add up the numbers before them. So the number that goes in this cell here, 30 plus 25. So there were 55 in category B. There were 55 students overall that had blue eyes. 18 plus 42 is 60. This is the number of students who did not have blue eyes. And then 48 down here, this column here is for students with blonde hair. So there were 48 students with blonde hair and 67 students without blonde hair. So this number and this number go here, 115, and it should be the same as these two numbers added together. So because it is, we know we've done something right. So I've shown you a two-way table that displays information about students' hair color, one category, and eye color, a second category. Two categories, hence the name two-way tables. So let's use this to answer questions about probability. So let's say I took a student at random. So what is the probability of B? That means what is the probability the student had blue eyes? So we just look at our two-way table. We see from this cell here, there were 55 students who had blue eyes out of 115 in total, and we can simplify that fraction. So probability I pick a student with blue eyes is 11 over 23. So what is the probability of A being in category A? So there were 48 of those students, out of 115. And we can't simplify that fraction anymore. Okay. Again, this is very, very useful if we want to answer those and, or not questions. So the probability that I'm in A or B. So that is the probability I have A, blonde hair, or B, blue eyes, or both, because I keep telling, and whenever I say A or B, I mean A or B or both, inclusive or. So the number of students that applies to, it's actually this cell, because these students have blonde hair, this cell, because they have blonde hair and blue eyes, and this cell here. So I add all of those up, 18 plus 30 plus 25, and I get 73, sorry. So there were 73 students who had either blonde hair or blue eyes or both out of 115. So the probability of A and B, so they had both blonde hair and blue eyes, that's easy. It's just this cell here, 30 over 115. This time I can simplify it, okay? So what is the probability, I'll do that up here, what is the probability of A and not B? So that means what is the probability that a student had blonde hair but not blue eyes? That's easy. I just look at this cell here, A and not B. There were 18 students out of 115 in total. What is the probability that a student does not have blonde hair? So that's what A dash means, not A. Or the student does not have blue eyes. So this includes all students who have a different eye color than blue. It includes all the students who have a different hair color than blonde, and all the students who have both of those things. So not A or not B. So not A, these two cells are both not A. They're students who do not have blonde hair, so I include them. I also include this cell here because it's also not B. So this cell and this cell are both not B, students who do not have blue eyes, and this cell and this cell are the students who do not have blonde hair. So the total number of students that either don't have blonde hair or don't have blue eyes or both, 18 plus 42 plus 25, 85 in total out of 115, and again I can simplify. Okay, so two-way tables, the idea behind them is very simple. We're just displaying information about two categories and the number of elements in each category to do probability questions. Now the last thing I want to show you is that I could put all of this information in the two-way table into a Venn diagram because they basically do the same thing. So remember, if I have a Venn diagram, I have two sets, A and B, so A, blonde hair, B is blue eyes, and there are 4 numbers that they go in these particular spots. So firstly, this middle number, the one that goes there, is A and B. So we look at our two-way table, that number is 30. There were 30 in A and also in B. This number here now is the number that were in B but not A, which is this cell here. So that number is 25. Okay, and then of course this one here is the number that were in A but not B, which is this cell of the two-way table. So then that number that goes there is 18, and the last number, which was not A and not B, is outside the circles, is 42. So each of these 4 numbers, 1, 2, 3, 4, has a special spot on the Venn diagram. And now this Venn diagram and the two-way table give exactly the same information. All right, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.